So here's my last technique of integration. It's probably the most unnatural technique that you and I have. It's referred to as a Weierstrass substitution. So please forgive me if my German spelling is incorrect. I do not speak any German at all. Now, if you don't mind, I'm not going to give you an example yet. So here, I'm just going to play it and derive some relationships out of thin air. I'll be honest with you. I don't use the substitution well enough to even remember the substitutions that I need. I only remember the first seed and generate everything else as I need it. So here we go. Here's the genesis of everything here. If I have in the integrand's position some kind of linear combination of sines and cosines, upstairs or downstairs. In other words, a constant times sine of x plus another constant times cosine of x, and the antiderivative of what's in the integrand's position is not immediate, then here's the substitution I commit to. Now, if I have x as my variable integration, I make up a whole new variable t to be this. But I need to replace sine of x and the cosine of x with something. So let's see what a pretty picture says about this relationship. To say its tangent is t means the ratio of this length to this length is t. That leaves me with this for the length hypotenuse. So would you agree? Now, can you appreciate how I really blew it? I'm the one who said, if I have some linear combination of the cosine of x and the sine of x, the inputs are x's, but these inputs are x halves. So to start talking about sine and cosine of x, I need my double angle identities. Oh, you know what? It's not going to work. I just need more room. There's an application of a double angle identity. Well, one of the three double angle identities for the cosine function. So there is a rational expression I can replace a cosine of x with in terms of t. Here's a rational expression in t I can use for sine of x. Now, as far as the relationship between dx and dt, do you recall that this is my original substitution? That implies this. That implies this. Now differentiate appropriately. This is the relationship between dx and dt. Next, I'll put this to practice.